All right, hi everybody. We're going to be graphing a sine and cosine today. So the first function we're going to be graphing is y equals sine of x. So let's make sure we're clear on what the x and y are. The x is the angle, and that could be in radians or degrees. You'll notice along the x-axis here, I've got 90, 180, 270, and 360 as my key points marked off. So of course I'm in degrees if I'm using those values. If I were in radians, it would be things like pi over 2, pi, and so forth. And I'll show you how to do that in a minute. But we're going to start with degrees because it's a little more familiar. So in here, the x value, that's your angle. The y value, which tells you how high up or low down our points go, that's the value of the sine of that angle. Okay, so how does an angle relate to its sine value? Well, we want to think about the unit circle. And if you haven't done the choice boards for understanding radians and understanding the unit circle, I would definitely do those first before you tried to do this one. I think it'll make more sense that way. But the gist of it is that as you go around the unit circle, starting with 0 degrees all the way to 90, 180, 270, and 360, all the way around, your sine value is equivalent to the y value on the unit circle. So it starts at 0. At a 30-degree angle, it would be 1/2. The reason this works is that if you think about a triangle, say from this 30-degree angle here, the opposite side of that triangle, and remember sine is opposite over hypotenuse, the opposite side of that triangle would be equivalent to this y value of 1/2. So opposite side is 1/2. Hypotenuse, of course, is just 1 because it's a unit circle with a radius of 1. So that's why on the unit circle we can trust that the y values are sine values. So we're basically going to start from a sine value or a y value of 0, and that's going to go in with a 0-degree angle. We get a 0 sine value. That's our very first point. It's at the origin, 0, 0. So this is where we start. We aren't going to necessarily worry about every single little one of these points in the unit circle. We're going to kind of watch the general pattern. We're climbing from 0 rather steeply up towards 1/2 when we're at 30 degrees, then up to square root of 2 over 2, square root of 3 over 2, and eventually 1. But the key thing to notice is we're starting at 0, we're going up to 1 by the time we get to 90 degrees, so we know this is a point at 90 comma 1. But we're not going from 0 to 1 in a straight line. So this isn't a linear kind of thing. We're actually going up a lot more at the beginning. It's steeper here. And then we're only gradually going up towards the end. So what we're going to have is, a line that isn't really exactly a line. It's more of a curve. It's going to be steeper through this first part, but then kind of leveling off and getting a little flatter as we go across the top there, because that's exactly what the unit circle does. It sort of slowly reaches its maximum and then slowly begins to roll over and head back down. So we want more of a curve, not a jagged V-shaped kind of line. So we hit 1 at 90 degrees, and then we start to go back down. We hit all those same key values, square root of 3 over 2, square root of 2 over 2, 1 over 2, and then eventually back down to 0. So we're softly going back down, but then steeper as we get towards 180 degrees, at which point we'll be back to 0. So this is going to be a point on here as well. So trying to continue just making that a nice soft curve across the top, but then getting a little steeper as I come through 180, because you notice through this section, it pretty much is a lot of up and down. We're rather rapidly moving down here. So 0 down to negative 1/2, then on eventually to negative square root of 2 over 2, negative square root of 3 over 2, and our very lowest point on the whole unit circle is at 270 degrees, where we're at negative 1. This is as low as this function will ever go. Sine values just simply do not go below negative 1. They don't go above 1 either. So this is the maximum, this is the minimum, and then as we go through the fourth quadrant, we're going to be heading back up again, slowly at first, but then a bit more rapidly and steeper at the end, and eventually we're going to get back to where we started, which makes some sense if you think about it, because remember that 0 and 360 are what we call coterminal angles. Okay, they're going to act exactly the same. They're going to have the same sine value, same cosine value. And if you were to continue, and this function certainly does continue, we would just start doing the whole same thing over again. We'd hit all those same y values like we did last time. So this part would repeat, into the next part of the graph right here, and we'd go back up to 1 and then eventually start falling back down again. This thing is just a wave, and it's just going to keep on going in that same pattern, and it even goes into the negative values. We'd hit -1. I should make that a little smoother there, but you get the idea, hopefully, that it's just a wave that just does a nice, smooth, kind of up and down, always hitting a maximum of 1, minimum of -1, and our key points happen on the axes, right at the corners, as we switch from one quadrant into the next. So notice those key points. They are important if you're creating the graph yourself. Now, as far as those x values, we chose to do degrees, and so that's why we had 90. But we could have chosen radians, and it would have worked just fine. Here's what would have happened if we had been in radians. My 90 would have been a pi over 2. You can see it right here on the unit circle, pi over 2. I'm typing it in with pi just because it's easier to type it that way on the Smart Notebook software, but you could write it as a pi symbol if you prefer. So this 180 is equivalent to pi. So of course, if you're working in radians, you would change all of them. So 270 is like 3 pi over 2, and 360 is like a full trip around the circle, which is 2 pi. And if you need a refresher on the radians, we got a choice board up for that. But you can always kind of use your unit circle, um, almost like a little cheat sheet, to make sure you're getting the right angles matching up. So degrees, radians, not a big deal. Just make sure if you're using a graphing calculator or Desmos, you need to make sure you're in the correct mode, and you can click the wrench up in the top right for that. But that's basically how you graph sine. Graphing cosine, instead of worrying about the y values and how high up we are on the unit circle, we're going to be looking at the x values. We'll get a similar wave, but it's going to kind of start and end at a different spot. So if you think of sine as measuring up and down and y values, cosine is measuring right left. It's measuring, how much to the right am I pointing? And we're going to be focused on the x values. So cosine starts with an x value of 1. So we're not starting at the origin this time. We're starting up here for a 0-degree angle. That's your x part. You have a cosine value of 1. And that cosine value, which is basically your x, it's how far you are to the right, it's going to shrink kind of slowly at first because we're not really moving very much to the left through this first section, but it's shrinking a little. And we're starting to move more left, even more left, and then rather rapidly to the left as we get to 0. So again, it's a soft curve that begins at its maximum and then heads down through 90 degrees. And then we end up down into the negatives because we get negative x values in the second quadrant. We're still moving pretty rapidly to the left. And then a little slower as we finish getting all the way to -1, which of course is our furthest left point. So that's going to be at 180 degrees. So we know this is a key point on the graph, and we're going to have to make sure we hit it. Doing my best to draw this neatly. Notice I kind of smooth it out towards the bottom. I may have even smoothed it out a little more than I should have, but you get the idea. It's not a sharp absolute value style graph. It's more like the top or bottom of a parabola. So we want to kind of smooth out those tops and bottoms. As we head towards 270 degrees, we go through the third quadrant. We're still negative. We're slightly less negative at first, getting more or less, I guess, negative as we head towards 0 for our x value. So we're basically just graphing that x value. And as we get up to 360, the end of the fourth quadrant, we're going to be back where we started. Notice from 270 to 360, we increased because we were heading over to the right into positive x territory, getting more positive and more positive, but slowing and only slightly more positive at the very end, hitting a max of 1. I could probably neaten up this little part of the graph right here. Just a little bit. Just want to try and make it kind of a nice, smooth, pretty graph as best I can. I want definitely some smoothness at the bottom, not a sharp V. This thing ends up looking sort of like a cursive V. So, and again, it would keep going. Um, so you can kind of show that by just giving yourself a little more on each side. And what we end up with, again, is a wave that hits maximums at 1, minimums at -1, and it crosses the x-axis at points in between. And the key points are those angles that are on the axes, those multiples of 90. And of course, you could do this one in radians too if you wanted. If you notice the difference between the sine and the cosine function, well, there's not really that much difference. It's the same kind of a wave. It repeats itself. It is the same maxes and mins. The only difference is starting point. Sine starts at 0, goes up. Cosine starts at 1 and goes down. So that's the key difference. If you want some more information on this, check out the rest of the choice board. There's an article, there's some practice items that you can try. So check that out, and we'll see you next time.